Okay, it's the top of the hour. So I'm going to start. Say welcome to today's webinar, everyone. It's hosted by the Sea Ice Prediction Network Phase 2, which is also known as SIPN2, and facilitated by the Arctic Research Consortium of the United States, ARCUS. Today's team includes Stacy Stout, Kuba Genda, Britt Myers, our Executive Director, Helen Wiggins, and me, Betsy Turner-Bogren. Today's presentation is the first in the 2020 SIPN2 webinar series organized by Muyin Wang, who is a member of the SIPN2 project team. Today's topic, Understanding Stakeholder Information Needs for the Sea Ice Forecasting, will be presented by Hajo, Director of International Arctic Research Center, Joseph Little with the Experimental Arctic Prediction Initiative at the International Arctic Research Center and School of Management at University of Alaska Fairbanks, Zeke Baker, who's a postdoctoral research associate at the University of Oklahoma and the National Weather Service Alaska, and Marta Torrado, Science Communication Specialist at the Barcelona Supercomputing Center. A link to an online survey will be available at the end of today's webinar. We appreciate any feedback you could give us, as well as suggestions for future webinars. Before our presentation begins, we have a couple housekeeping items. Next slide, please. When you entered the meeting room via Zoom, your video was switched off and your audio was muted by the host. Please keep your microphone muted to help prevent disruptions and background noise. Your Zoom controls, chat, etc., can be found by hovering your mouse over the bottom of your Zoom window. We could recommend that you use the chat feature during today's webinar, which will let you chat with individuals or the whole group. Next slide, please. Questions will be addressed during the question and answer session following the presentations. If you're joining by Zoom, please type your questions into the chat window at any time. I will record them and read them aloud during the Q&A. If you're joining by the YouTube live stream, please type your questions into the live chat window. A facilitator will share your questions with me to read aloud. And if you are joining by phone, you will need to raise your hand by pressing *9 and unmute yourself by pressing *6 to ask your question aloud. For technical support, please contact Kuba Genda via chat or email Kuba, K-U-B-A, @arcus.org. And we'll have this slide at the end of the presentation for reference. Next slide, please. This SIPN webinar event is organized by Muyin Wang. Muyin is a research scientist at NOAA and the Joint Institute for the Study of Atmosphere at the University of Washington. Muyin, at this point, I'll turn the program over to you.
Thank you, Betsy. And good morning, or good afternoon, good evening to everyone. First, I'd like to thank you all for participating in our webinar in this special environment. I hope you are all well. So the theme of today's webinar is Understanding Stakeholder Information Needs for Sea Ice Forecasting. This theme is motivated by our SIPN2 research objective, that is to improve forecast skill through adopting a multidisciplinary approach that includes modeling, new products, data analysis, scientific network, and stakeholder engagement. So today's webinar will start with a short summary on spatial and temporal needs of sea ice forecast by Dr. Hajo, Director of the International Arctic Research Center, also a member of our SIPN2 leadership team. Then we'll be followed by other three presenters. First is Dr. Joseph Little, Professor of Economics from the School of Management, University of Alaska Fairbanks. Joe received his Bachelor of Arts degree in International Political Economics from University of Puget Sound in 1996, and a Master and a PhD in Economics from University of Denver and University of New Mexico, respectively. He became a faculty in UAF since 2005. Joe's research interests are applied macroeconomics, environmental economics, and non-market valuation. Joe is also a member of our SIPN2 leadership team. The next speaker will be Dr. Zeke Baker, currently a postdoc research associate at the University of Oklahoma and the National Weather Service Alaska region. Zeke received his Bachelor of Arts from Wheaton College in Sociology in 2009, and a Master and a PhD from UC Davis in the Department of Sociology. In the coming fall, Zeke will become an assistant professor in the Department of Sociology, Sonoma State University in California. Congratulations, Zeke. Zeke is a sociologist whose research uses a historical and qualitative method to understand the development and use of environmental climate science, especially insofar as climate knowledge is embedded in social relationships of. Our last speaker will be Marta Torrado, a communication specialist in Earth Science Department of Barcelona Supercomputer Centers in Spain. Marta received her degree in environmental science from Autonomous University of Barcelona in 2003. She then received her master's degree in geophysics from a Polytechnic University of Catalonia and a PhD in Earth Sciences from University of Barcelona. Today, she represents the user group to explain how user engagement applicate improve project scientists' understanding of stakeholders' needs to be able to develop products that are tailored, relevant, and useful. Applicate is an EU Horizon 2020 project, stands for Advanced Prediction in Polar Regions and Beyond. Last September, in our SIPN2 webinar series, Dr. Pablo Ortega gave an overview on the Applicate project, and webinar was recorded. So I think Britt will post the link to that webinar. If somebody missed that webinar and interested to see again, you can view that through the link Britt posted. So right now I also have turn the speaker to Hajo. Please start. Thank you.
Thanks, Nguyen. I appreciate the opportunity to just give a brief perspective on the broader landscape of regional ice prediction products and associated information needs. I see there's great turnout, so I look forward to discussing some of these issues in more detail down the line. I just wanted to highlight that some of what I'm reporting on here derives from information provided over the years by various ice information users in Alaska, in particular through the National Weather Service, and others such as the CS for Walrus Outlook, which is currently underway. So you can visit some of these sites on your own. I also want to emphasize that a lot of what you'll be hearing about today addresses the importance of so-called co-production approaches, and so co-production of knowledge, co-production in terms of determining information products that are actually relevant for different users. The graphic at the right here gives you a broader perspective of the three things that matter in terms of ice uses and operations and information that's relevant for ice users. This is with a focus on the coastal Arctic, but you'll see that all of these areas are going to be covered by the presenters today in terms of different ice users, in terms of different examples of ice use, as well as in terms of different parameters that are impacting ice use. So you'll hear a bit more on the larger scale uses from Marta Torrado and Joe Little. Zeke Baker is going to cover more the coastal community perspective. And in particular, Marta and Zeke are also going to give you a good perspective on co-production approaches. The next slide just gives you a quick perspective on how sea ice matters from an ice use as well as ice hazard perspective. So the key point to remember is that some ice users are interested in learning more about the presence or absence of ice because it's a major hazard to their operations, and Joe will be talking more about that. And gaining that knowledge over different timescales from the operational synoptic weather timescale all the way out to the seasonal timescale is of course associated with significant challenges. That's something that you'll hear more about in the different presentations. Other ice users are more interested in the quality of the ice, and I'll give you a brief example here in a minute. And that's one of the larger challenges I see we face is providing skillful predictions of information about the ice that go beyond just presence or absence or ice concentration. And again, I've already pointed this out. The presentation today cover a range of key ice user groups. You'll see this here. in terms of who you'll hear more about or from in terms of ice use. The next slide illustrates this question of what are the key aspects or attributes of predictions that we have to focus on. The prediction needs, of course, always are driven by the context within which that information is used. And again, it'll be interesting to explore this a bit more in the discussion, whether as CS researchers or prediction services, we have a good understanding of the decision-making and planning context. You'll hear a bit more about predictant variables in terms of ice extent quality, but the seasonal cycle and key events in the ice year, very simplified version is something you see on the right here on your screen, are also important to keep in mind, in particular from an extended use perspective. And that's something to look at in a bit more detail in the different presentations as well. Today's presentation cover all the relevant spatial scales from the community through the regional to the Pan-Arctic, as well as different time scales here, from hours to days out to the subseasonal, seasonal. And the latter is in particular relevant from the perspective of access to various regions that contain sea ice as a potential hazard, as well as ice use. And in that latter context, interesting question to listen for and maybe discuss in a bit more detail is this question of what is the uncertainty that different ice information users are willing to tolerate from an economic or risk perspective. It'll be interesting to see whether we have good understanding of that. And the final slide, just to give you a bit more of a granular perspective on the ice cycle, I'd like to highlight some observations taken over the course of a decade by Winton Weapuck from Wales, who passed away sadly a few years back, but he helped compile or contribute a very significant record of both the seasonal ice cycle in terms of different events for his community of Wales and Bering Strait. So you see different events in the ice year, such as appearance of first ice or ice hazard information that, of course, from a prediction perspective, is to be treated very differently from the longer range perspective of, for example, presence of stable landfast ice in the coastal area and how that translates into different uses. So with that, this was just meant to give you a brief overview of what to expect in the talks. I look forward to the presentations and a productive discussion. Thanks.
Hi, everybody. Good morning. Thank you for being here. It's exciting to be a part of this webinar. I'm going to be briefly covering some early findings and insights from a survey of the Alaska Bering Sea crab fleet that will be taking place or continuing to take place through the month of May. Next slide, please. Quick thank you going out to Alaska Bering Sea Crabbers, Executive Director Jamie Goyne and Jake Jacobson have been critical to this help, collaborators with SIPN2, ARCUS, and then funding support from the National Science Foundation and any others that I may have forgotten. Next slide, please. The survey was fairly straightforward, so I wanted to provide an overview of the structure of the survey, its content, just basically looking at what kind of viewpoints crabbers had with respect to a 1-month forecast for sea ice in the Bering Sea. Early insights that we're going to address include the utility of operations or utility to operations with respect to a forecast, how they use sea ice information now. And then we want to look at attributes that they would value in a 1-month forecast. There were a number of challenges in trying to conduct this research during a pandemic, and so that relates to the currently small sample size. Next slide, please. If we were to look at the Bering Sea crab fishery, it's a commercially important fishery in Alaska. It comprises about 23% of ex-vessel value. That's first off the boat value for crab, and it's a commercially harvested fish in the Bering Sea, Aleutian Islands region. It's about $220 million based on a McDowell group report in 2017. Typically about 75 to 100 crab boats operating in the Bering Sea in a season, which runs from the middle of October to the middle of May typically. They use the National Weather Service short-term or synoptic sea ice forecast to support their operations. There's an undefined need for seasonal scale forecasts, and that's the reason why we conducted the survey. Next slide. If you were to look at the survey focus, along with the background, with respect to their experience operating in the fleet, we also wanted to look at their viewpoints of operating near sea ice edge proximity, how sea ice has impacted their fishing, their timing of forecast, which months in particular they would like information for, how they would use this information. What really stood out in the survey is to support safety. And finally, that information can also be used to support where they're going to fish. So those are two early insights from this focus group. Next slide. Now, as I mentioned before, there have been a number of challenges with respect to how COVID-19 has impacted the fleet operations. So it's probably best to look at this early survey as a focus group that we can use to extend our work this summer. There should be opportunities for future stakeholder engagement when things settle down. And I mentioned before, we're planning on running the survey through May, and then we'll do another follow-up survey later in the summer. Next slide. We had 13 respondents. There were 12 crab boats and 1 cod boat in the fixed gear fishery. There are also boats that go out fish for cod. On average, our respondents had about 30 years of experience operating. Their range included 16 to 40 plus years operating in the Bering Sea as a crab boat captain. Their primary species that fished include snow crab and red king crab, which happen to be the most economically valuable. And an interesting point here in looking at synoptic scale sea ice forecast, all of the respondents reported checking the National Weather Service sea ice forecast at least every other day, and 6 individuals indicated reporting that they checked it more than once per day. So it's an important input for their operations. Next slide. Now, if you were to look at past negative experiences with sea ice since 2005, and that was the date of the rationalization, crab pots are very expensive. And so many of them reported losing gear to sea ice. Importantly, they also lost days fishing, which translates into lower harvest and translates into lower income. And then finally, some reported vessel damage bumping in the ice when they're out in the water. So with respect to the survey, the respondents are willing to operate in open drift with small flow, and some are willing to operate in open drift with larger flow. No respondent indicated working in pack ice. Next slide, please. What's interesting, if you were to ask them if fishing's better near the ice edge, almost all the respondents in this case said yes. And how close they were willing to get really depended on kind of how they responded to that question. So on average, they were willing to work about 20 miles to the sea ice edge. And then secondarily, you had one individual that was willing to work only 60 miles of the sea ice edge. Next slide. Just some insights coming from comments. From the standpoint of the crabbers, making an educated guess and having information to help inform that guess is important. It can help them plan for where they're going to fish, and also can help them plan for their deliveries. So that actually helps reduce cost over the long run. In many instances, they've had an experience where sea ice has moved them off of good fishing grounds. So having longer term information can be helpful from that standpoint too. In addition, you also look at many cases if they have to reset or move their gear before they deliver their harvest. Next slide, please. Now, we asked them how a 1-month forecast for sea ice would most benefit their operations. And some of the options included safety, route planning and navigation, resupply, fuel purchases, and some other items. With respect to this outcome, 6 respondents indicated that a 1-month forecast would most primarily enhance their safety with respect to operations in the Bering Sea. Some additional insights seen on the next slide include impacts on the choice of fishing location. So if you were to look at the catch per unit effort with respect to where they would like this information, it makes sense that having it in the Bering Sea near the crab fishery is important. But from the standpoint of being able to set their pots and not have that ice impact their sets, that information is critical. And then finally, the timing of delivery is also important. This is particularly true for St. Paul, as all the respondents indicated about 3 transits in and out of St. Paul in a given year. Next slide. We executed a heat map just to identify where folks would want information for 1 month in advance of the forecast. And so on this heat map, we just obviously placed it up there. They could click and identify the preferred locations for fishing. And so naturally those extend roughly in line with what we see with respect to the NOAA's CPUE, or catch per unit effort. So having information in those highlighted areas about whether or not sea ice is going to be present in the near future, 1 month out, would be of use to the respondents. On the next slide. there were some concerns with respect to whether or not this would be an accurate piece of information, and that kind of speaks to Hajo's comments with respect to uncertainty. So this is going to be an area we want to explore further in the future. Now, from the standpoint of locational choice and being able to fish, having that information with respect to a forecast in the Bering Sea would help them make that decision, but it's obviously going to be the case that there will be some questions as to its accuracy and how uncertainty can impact that. So they're probably going to use other pieces of information with respect to their sea ice decisions. Next slide, please. We also wanted to look at attributes for the ice that they would like having in the forecast, as well as which month they would most like to have a forecast for. From the standpoint of attribute-based information, location and extent ranked the most highly from respondents, and direction came in a close third. From the standpoint of forecast month preference, January and February ranked the most highly, and then April, interestingly, swapped out with March as the third most important attribute ranked by the respondents. Next slide, please. Just some closing comments. The survey is still a work in progress. This work's going to continue through May, as I stated earlier. Respondents have expressed interest in longer run sea ice forecast, particularly with respect to location, extent, and direction of the sea ice. It's most useful for safety and helping determine fishing locations. Now, the next questions we have for future steps is how to convey this information, to convey forecast info to stakeholders. And then also we want to start expanding this out to evaluate use by a forecast for a subset of ships. So if we want to look at differences in experience or different type of vessel classes and how they would use this information. Next slide. Thank you. If you have any questions or comments, feel free to contact me at jmlittle2@alaska.edu, and I appreciate your time this morning.
Thanks, Joseph. I'll just hop right into it. Thank you all. The title of my talk, I'm Zeke Baker. The title of my talk is Anticipatory Culture in the Bering Sea, Marine and Sea Ice Information in Sociological Perspective. This project is motivated by the fact that the capacity of Bering Sea communities to anticipate the future from the short to long term stands in question. The goal of my larger project is to incorporate community perspectives and needs into the operational context of the United States National Weather Service, their products, their messaging, and their policy regarding marine and sea ice forecasts. So it's with them whom I am working with this project. Thus, my research question, which is on the screen now, regards the value of marine weather information to decisions and livelihood made in the Bering Sea environment. Next slide, please. The terms of that question, the values of information and how it informs action do not happen in a vacuum. Rather, they happen in a context of change on multiple fronts, including scientific innovation in forecasting as a primary example, community level changes and policy changes, and of course, environmental climate change impacts on weather and on ecosystems. Next slide, please. To address that research question, I'm not working to refine predictive skill. That's not what I do as a sociologist. Rather, I'm studying how people act with reference to their understanding of the future, of which formal information is but one part. I call this anticipatory culture, which, as I'll lay out in a short bit here, is beset by what I'm calling temporal dissonance or difficulties around anticipation at various timescales. But first, next slide, please. I'll lay out what the study looks like that I'm doing. Oh, sorry, back one. Thank you, right there. I conducted, this is a 12-month study, this postdoc. I conducted research on Alaska, on the Aleutian Islands. That work, so a lot of it was with commercial fishermen, was supplemented with research down in Seattle at the Pacific Marine Expo. The second research site was St. Paul Island in the Pribilof Islands, where I spent January and February doing field work. And research in Nome, for obvious reasons, is on hold at the moment, although intended to be up there during breakup, and that'll be at a future time. And I put NWS, National Weather Service Alaska, in there because a lot of what I've been doing is shadowing and working with forecasters there to understand how we get from production of information to the products to the user. Thus far, I've completed 36 semi-structured interviews. That's not counting work with Weather Service, in addition to observational research, some outreach, and shadowing. These findings that I'm going to present are preliminary. Everything I have transcribed, and I'm coding, and I'm using qualitative data analysis to do my analysis on what I have thus far. Next slide, please. I'll just highlight three preliminary findings and what are really three dissonant timeframes of anticipatory culture that I think should impress upon how producers of predictive information, how they relate to stakeholders. The first is a long or generational timeframe in which marine weather and sea ice patterns register as a sign of dramatic climate and ecosystem shifts, which in turn complicate how people envision themselves as inhabiting both a long-term history and a long-term future. So one tribal leader, for example, and lifelong mariner in Unalaska described to me the pre-invasion Bering Sea as, quote, the school of 8,000 years, the lessons from which have been largely lost or are under threat. For some residents of St. Paul, the colonial history of the Pribilof Islands is tied up with an uncertain future. Declining human population on the island, changing economic prospects, difficulty reviving local culture and language, climate and ecosystem shifts. These changes register as of a whole rather than as separate issues. Therefore, while I was on St. Paul in the winter, local residents awaited the return of the sea ice this winter with keen anticipation, which did not totally transpire, but it was a large ice year in the Bering Sea. For them, the sea ice signified the vitality of the ecosystem, which marine ecology supports, and a sense of environmental security. Next slide, please. A second preliminary finding regards a situation of unanticipated seasonality, so the seasonal timescale. One elder with whom I spent quite a bit of time in St. Paul, who performs ecological monitoring and is also a subsistence hunter and fisherman, put it this way: it shouldn't be like this in his evaluation of the island, noting weather changes, vegetational changes, different coastal processes, that to him indicated larger changes in the very nature of seasons. The fur seals who were overwintering on the island were particularly alarming. They're regularly migrating at the time. Unpredictability in seasonal weather patterns, in also fish behavior and related economic uncertainty. Some small boat fishermen in St. Paul told me that this opens up the door to weather risk, to hazards to their operations, because, for example, they must then move offshore to new waters in new weather situations, which is especially compounded by an uncertain fishing season. For commercial crabbers at the seasonal level, the present real sea ice season has meant dealing with either familiar, like from historical perspective, familiar years, or very unfamiliar conditions, depending on how long one has been operating. On the basis of risk evaluation, weather information, and perceived skill among the captains whom I interviewed, sea ice over the course of a season is variably something to be monitored and to be avoided entirely. Something that shapes decisions regarding where and when to fish, as Joseph Little's presentation emphasized, and in some cases, something to be used strategically in cases of using sea ice as protection from wind, swell, and the associated freezing spray. Next slide, please. Third, regarding the timescale of forecasted weather. For all mariners I interviewed, getting and interpreting weather forecasts amounted to a kind of religious observation in a way. But this is a syncretic, messy religion, if it is, and there's a lot of uncertainty and dissonance yet. And this was surprising to me in a lot of interviews. The source is not only the weather itself, but more so the changing informational environment that comprises or complicates really decision-making around forecasts. So with increasing automation of weather forecasting and, on the other hand, internet-based tools for users, and internet is widely available on a lot of these larger ships. This is a crab ship on the slide there. Many have turned to internet-based graphical apps. You know, as one fisherman put it, quote, "Fishermen out here, we live and breathe by the Windy app." That's universal, by the way. When are you guys, meaning the National Weather Service, going to be catching up, end quote. So this situation regularly presents cases of confusion. Another quote, "Windy, Windfinder, and National Weather Service, I look at all of them, then compare. The trends are often close for all of them, but the timing can be way different." A lot of information like that. Regarding sea ice, however, mariners rely almost exclusively on the NOAA ice charts put out by the Alaska Sea Ice Program. It is noteworthy, though, that no commercial fishermen whom I interviewed used any sort of longer range outlooks with any regularity. Regarding explicit needs for subseasonal to seasonal level prediction, there are two patterns that emerged from my interviews in Alaska and St. Paul. First, people want predictions of if it's going to be a heavy ice season, which doesn't only impact fishermen, but also impacts harbor operations and fish processing, which is interested in that larger, somewhat larger time scale beyond the weather window. Second, people want integration of sea ice information into existing products and tools that they use. So that means, as some examples of what I've heard, day-by-day graphic displays of sea ice projected movement and sea ice characteristics, either on existing charts like the National Weather Service charts, or integrated into tools they use like Windy. Next slide, please. By way of discussion, work and shadowing with National Weather Service forecasters, I think, provides some guidance on how prediction efforts might actively shape anticipatory culture. There's gaps and limits to the three principles I'll kind of just sketch out real quickly here, but they're there. The principles, I think, are there. The first is the routine stance for information producers of thinking like a user when producing a forecast, especially under time pressure. Forecasters are pretty good at trying to do this. The second is issuing warnings and messages that take into account both meteorological thresholds for an event or phenomenon, as well as user impact thresholds, and skillfully combining those two. The third is the maintenance of social interaction. I mean, you know, look at us in this situation. That's good for us. But social interaction between producers and users for users rehumanizes weather services, which they just view as automated a lot of the time. And embodies the credibility in those forecasts. And for forecasters, it enhances their capacity to consider user situations in the otherwise removed context of the Weather Service office. So in conclusion, when faced with the problem of anticipating the future, work in this field has emphasized the development of products and tools that are undoubtedly important to formal prediction. But what may be just as important is finding innovative ways to coordinate the formal and the everyday anticipations of the future, especially insofar as those anticipations are at present burdened by dissonance at the generational and the seasonal and the everyday time scale. Thanks. Next, I have a thank you slide, but yeah, thanks. You can feel free to contact me and follow up in any way.
Okay, so hello everyone. My name is Marta Terrado, and in this presentation, I'm going to explain the user engagement work that Dragan Abojovic and myself are implementing in the framework of the Applicate project. Next slide, please. In a nutshell, the main objective of the Applicate project is to develop enhanced predictive capacity for weather and climate in the Arctic and beyond, and to determine the influence of Arctic climate change on Northern Hemisphere mid-latitudes for the benefit of policymakers, businesses, and society. And I have highlighted this last part of the sentence because I think in this presentation, this would be the key concept, these benefits for stakeholders that are beyond academia. At the bottom of this slide, you can see the logos of the different institutions participating in Applicate. Next slide, please. So I would like to start by describing what we understand by knowledge co-production, which includes the collaboration among different, what we call knowledge holders, including various scientific disciplines and also stakeholders from different groups. In Applicate, we built on the WMO's guidance on good practices for climate services user engagement. And this framework can be equally applied to the generation of other types of knowledge as well. For instance, CI's knowledge. The approach that we have taken consists of 3 different interconnected steps that in which the type of user will change according to how engaged, how much or how less engaged this user is. Click next. So in a first step, we have stakeholders that are engaged through awareness raising. This engagement is a more passive way of engaging, which consists basically on the provision of information. And this is done through websites and other web tools like social media or blogs. Next click. Then once the stakeholders are engaged, they become potential users and they get involved through the exchange of knowledge. In this case, the engagement is not that passive, but there is a dialogue and we use more interactive group activities, for instance, webinars, user forums, workshops, or interviews. Next click. And finally, once the stakeholders are involved, they potentially become what we call champion users. Champion users are stakeholders that have a more active engagement, and here is where the empowerment process comes, and these users are involved in the co-development of knowledge or services. These users can potentially can act like ambassadors in their sectors, so they can bring the research, the outputs of our research to the sector. And this is a more targeted way of engagement, and for that we can use also different tools like case studies or the development of prototypes or operational services. And in the context of the Applicate project, we particularly have been working in the development of case studies. Next slide, please. So in Applicate we use different tools. Click next. One of these tools is the user group, which consists in different experts that provide guidance to the project research, and I'm going to describe it later on. Click next. We also have a blog, which is called Polar Prediction Matters, and it's run by the Year of Polar Prediction and has the participation of 2 projects, which are Applicate and Blue Action, that contribute to the blog. Different articles that have been written by users can be found in the blog, and some of them are about CIs. So I would strongly recommend you, if you are interested, to check these articles, because you can learn more about which are the actual needs of these users. Click next. We also participate in workshops and organize side events at relevant conferences. This is another way to interact with stakeholders. Click next. We also take part in the EU Polar Cluster, which is a cluster of polar research projects. Some of them also have tasks on stakeholder engagement, so they conduct activities to interact with the stakeholders. So taking part in this cluster allows us to exchange information that in the end is of mutual interest for all the projects. Click next. Also, as much as possible, we try to team up with early career scientists. In the case of Applicate, these students got involved in the development of some of the case studies that we developed. And this was great because on one hand, they were providing very, very nice ideas. But on the other hand, students could also broaden their views about which was the actual application of science. Click next. And finally, as I have mentioned, we develop case studies, which is a tool of collaboration between climate scientists, stakeholders, but also other disciplines more related to communication and social sciences. Next slide, please. In terms of the user group, I'm going to describe it a little bit more now. It's composed by 10 qualified representatives from different sectors, including the scientific community and international organizations, also the public and private sector, and society, including local and indigenous communities. Click next. The aim of having a user group in our project is to have a comprehensive overview of the different issues that stakeholders need to face in the Arctic, also to get advice and feedback to the project research. And the user group also helped shaping data into relevant information and services. Click next. However, there are also challenges when you are setting up a user group. Some of these challenges are to find the stakeholders, and also to keep the gender balance. Another one is to ensure an equal contribution, because normally when you have a group, there are some people that tend to contribute more to the discussion, and others are rather more shy and more silent. Another challenge is to ensure a non-biased sectoral and geographical coverage, which is almost impossible, because at the end of the day you have 10 people that come from different areas. So there is a risk of overgeneralization sometimes, and not to capture the complexity of the area under study. Meetings have also been a challenge, because stakeholders are spread all over the Arctic, so meetings online were not easy. At least we had to organize a couple to allow the people in all the time zones to attend. And when possible, we try to meet face-to-face in relevant conferences, and also at the project General Assembly. Another issue or another thing to keep in mind was that the participation of the user group was in kind, so they were not receiving anything in exchange. They were not committed to deliver anything to the project. So that's why it was so important that at least in exchange of the time that they were devoting to the project, we have to understand that we have to deliver something and bring the results that we obtain back to the user group. Next slide, please. From the interactions that we had with the user group, but also with other stakeholders, we got some lessons learned. And here I will share a couple with you that have been already mentioned in the talks of the other two speakers that were talking before me. One of these lessons is that each stakeholder is unique. As you can see in this slide, there are 3 different types of stakeholders. All of them have a need of information on sea ice. For instance, if we look at the Icelandic Coast Guard, he or she will need sea ice information in order to undertake search and rescue operations. When we look at the Inuit local hunters, these people also may require information on ice conditions, just to know if it is safe or not to go hunting at a particular place, because maybe they need to step on the ice, or they need to move on it using snowmobiles, for instance. And then we have the captain of an icebreaker that needs to develop some sea transportation and ice-breaking operations, and for which it is important to know whether there will be ice or not. So whether next winter will be cold, and then there will be plenty of sea ice, or it will be warmer than normal, and then there will be lots of open water. So as I have said, users with different backgrounds, some of them more technical, others that probably don't have any technical knowledge, but they rely on traditional knowledge. Users with different types of decisions and with different information needs. Click next. So at the end, there is no one solution that fits all, and this happens even within the same sector. Next slide, please. A second lesson learned is that stakeholders make decisions under different contexts. Here, if we come back to the local hunters, we can see that they mostly are in need of immediate and day-to-day information to take their decisions, which basically look for their survival. They were to ensure that they develop their activities in a safe environment. So they are looking for almost real-time tools that can document ice conditions. However, if we look at other users like a ship crew, they can have other information needs, for instance, short and mid-term information to advise operational and management decisions. And these users would probably like to have some information to optimize their cost of navigation. So sea ice predictions for the next weeks and months could be a nice asset to them. And finally, if we look at policymakers, they have to take long-term regulatory and planning decisions. For instance, to finalize a policy on climate change adaptation. And for that, climate projections, which are long-term, could be more useful than other types of information on sea ice. Next slide, please. So as I said, in Applicate, we are developing case studies. And for us, this is a way to take all this feedback that we get from the user group, all these lessons that we have learned, and try to see what the project can provide to all these stakeholders, or to not all of them, but to particular stakeholders. And then we do it through case studies. Click next. In the framework of the project, we define case studies as particular extreme events in the past Arctic weather and climate that have an impact on specific aspects of the society or the economy of Arctic regions and beyond. And what is particularly interesting is that these extreme events have been identified by the stakeholders themselves. Click next. So case studies are useful tools to communicate how project outputs are useful for different stakeholders. So for moving from models and data to actual decision making. Click next. They are also useful to collaborate with stakeholders in this co-production framework that I have already described. Click next. They are helpful to showcase the utility of weather, climate, and sea ice predictions, because they show how this information would have been useful if available at the moment of this particular event. Click next. In the same line, they are useful to compare the impact of decisions taken with and without this information. Click next. And finally, they are also useful to identify which are the research gaps. And next slide, please. So here I'm going to just summarize one of the case studies that we developed in the framework of the project, which analyzed a winter cold spell that had impact on the energy market. The title of this case study is "How Does Arctic Sea Ice Affect Energy Production in Mid-Latitudes?" And if you are interested, you can download it at this link, where you can find also other case studies. Click next. So the event that was identified by users was was a cold spell that took place in January 2017 in France. And as you can see in this piece of news, the title is "France Cannot Meet Its Own Power Demand." This event was identified by stakeholders involved. These stakeholders were actually energy companies involved in the S2S4E project. This project stands for sub-seasonal to seasonal predictions for energy. Next slide, please. Click next. So what we did to analyze the case study was to keeping in mind that the cold spell occurred in January, we looked at what happened the previous months in the Arctic. So we were looking at the sea ice concentration, and we saw that the sea ice concentration was at its minimum record during November and December 2016 in the Barents and Kara Seas. As you can see, this region is the region that is inside the red box. Click next. Then, as I mentioned, in January, 2 months later, in January 2017, there was a cold spell in France. You can see in this map, the first one is a map of temperature anomalies. So you can see that the temperature was lower than normal during this week. And then when looking at the wind and precipitation, we can see that they were also lower than normal, which means that the resources available for renewable energy production during this week in France were also lower than normal. Click next. But on the same time, because of the cold spell, the energy demand in the country had a peak. And actually, it was an event that corresponded to a once in 10-year cold spell. So this was especially crucial at that moment because in France, most of the domestic heating systems feed on electricity. And on the top of that, during this period, a nuclear shutdown took place because of maintenance and inspection of the installations. So obviously, this event had not been predicted in advance. Nobody could have thought that this was going to happen. Click next. So this case study suggests that a high reduction of Arctic sea ice may have favored a record-breaking low precipitation and wind speed over parts of Western Europe. Click next. This contributes, the case study contributes to understanding the linkages between the Arctic and mid-latitudes. Click next. And once better understood, we can think that a future forecast of extremely low sea ice extent, that as we have seen in this particular case, also related with forecast of electricity demand and supply, could be potentially valuable for adaptation and also for assessing the risk for the European energy systems. Next slide, please. So I would like to finish this presentation by providing some highlights on what can the sea ice forecasting community learn from interactions with stakeholders. Click next. So first, you or they can learn to frame research in the right way to provide solutions to real-world challenges. Click next. Also to provide information that answers the needs of stakeholders, so information that it's timely, that it's coming in an adequate format, so in a suitable spatial and time resolution, and also in a format that can be maybe incorporated easily in the in-house decision making of a particular company, for instance, or a particular stakeholder. Click next. Also, another lesson learned is that it's important to develop skills to communicate scientific results to people beyond the academia, that for sure they need another language to be able to follow the explanations. They are not climate experts. Click next. And then to finalize, I would like to mention an online course that was organized among Applicate, JOB, and the Apex, and it took place at the end of last year. And during this online course, students had a task about developing case studies with the purpose to take the knowledge to the society. And I would like to just read one of the quotes that one of the students wrote in the survey at the end of the course, that was: having to explain my work to someone else helped me to have a clearer idea of what I was doing and why, and see how this work could also be useful for society. And I think this, even if this is very simple sentence, this is very relevant. Next slide, please. So I would finish my presentation here. I thank you for your attention. I give you my contact details if anyone is interested either in contacting me or the Applicate project. You can do it in the stakeholders@applicate.eu email address. And also I leave you the link of the blog Polar Prediction Matters if you are interested in checking the articles. Thank you. And that's it. You can skip
Thank you,
this.
Marta. Thank you to Hajo, Joe, Zeke, and Marta. Those were really good presentations. Those were excellent. We're now going to begin our question and answer session. We have a little over 5 minutes, but I wanted to remind you that if you want to ask questions by Zoom, type your questions into the chat window at any time, and I'll read them aloud. If you're joining by Zoom live stream, type your questions into the live chat window, and Helen will share those with me to read aloud. And if you're joining by phone, you will need to raise your hand by pressing *9 and then unmute yourself by pressing *6 to ask your question. The first question that we have came from the discussion. It was from Renee Tatuska, who joined by live stream, and she asked, to what extent is the SIPN2 network working with NOAA to create requirements to enhance National Weather Service sea ice modeling and forecast products? And Robert Grumbine seconded that question. Hajo, I think you'd probably be the best one to respond to this.
Well, and Zeke can chime in, but I already posted this. Joe, I thought did a very nice job in highlighting some of the interaction that helps identify regions where information is of greatest use. There's a number of other links that I'd be happy to discuss in more detail. You know, this extends out to maybe that the requirements for sustained observations are such that they can help improve some of the NOAA models. So I'd like to point to the Arctic Observing Summit that we included, where there was good engagement from the NOAA modelers as well to help ensure that you know, there's relevant information being collected. I see that you also referenced, Renee, the WMO regional climate centers. So I've been in touch with people to see how part of the Arctic Observing Summit we can have more of a regional focus on how to improve products. And that's actually, I'd like to push the question back because one of the things you find is, you know, and that's a conclusion also from working with the Weather Service and other local users, is that of course, information is most relevant at the scale where decisions are being made, and a lot of the decision making is at the local scale. I'll post a link here to a paper that Nathan Kettle led that actually did complete a quite detailed analysis of what type of information is useful for the National Weather Service and what the challenges are in terms of then scaling up from the local to the regional level. So I'd encourage you to look at this some more. I see Dina Abdel Fattah with IARC is on the call as well. She actually is working on another study that expands on this a bit more. That's the key challenge. You know, how can you make sure that whatever you find at a particular location where a case study is conducted can then be scaled up on an operational scale from a prediction services perspective.
Thank you. And it looks like there's a lot of discussion that can go on, and people are probably seeing that in the chat as a follow-up. Robert Grumbine says that, well, what Hajo says is true. It doesn't really address getting a requirement acknowledged in the National Weather Service, a very different process than identifying what user wants and needs are. But seeing short on time, I think I want to switch to a different topic. And this was asked by Alice Duvivier, and she says, I would like to know if there are more concrete parameters that people use to define ice quality. This seems to be something that people could tell intuitively, but has anyone tried to pinpoint parameters a forecast could provide that could help one determine ice quality, i.e. internal temperature, etc.? Is that, I'm wondering if maybe Hajo, you could continue to respond to that, and then maybe Joe, maybe any of the others could step in.
Yeah, it might be interesting to hear from Marta on this, what the European services are doing. But I mean, so ice quality is a good example, you know, so I'd like to also respond to Bob Grumbine. I mean, the person who pointed this out was Don Moore, who's with the National Weather Service here in Alaska, who in communications indicated that that's something that is coming up through the process that the Weather Service uses by requirements. But ice quality is a very general term, right? That's the role of prediction networks and the research community to work with stakeholders, information users, to drill down and say, is this ice thickness? And if it is ice thickness, is it the mean ice thickness over a given area? Is it the maximum ice thickness? You know, there's a range of other things. You know, ice temperature can play a role. That's been used by the Canadian Ice Service to better describe the rheological state of sea ice during the breakup season. And actually ice temperature is currently still state of the art of describing the load bearing capacity for sea ice that's used, for example, for sea ice runways by people who are landing planes on the ice or moving equipment across the ice. So all of those variables need to be very clearly defined and then linked to some specific use. But Marta, it would be interesting to hear from you and see what's your sense on the European side in terms of what aspects of ice quality seem to matter most and how to best get at those.
I think we're right at the end, so a quick response from Marta, and then we'll switch to providing a link for feedback. Thanks, Marta. Go ahead.
Yeah, actually, it's very difficult for me to say which parameters of ice quality would the European side, let's say, be interested in. I can only tell you that in the case studies we have been focusing, we are using sea ice concentration, but it's just because this was the information that we got available from our scientists in the project. So I'm not sure this is something that was a requirement. I mean, we were looking for information on sea ice, but we were not paying actually attention on which parameter was the most important.
Thank you. Stacy, could you go ahead and thank you. Go to the thank you slides. One back, just to remind everybody that we really appreciate everybody's participation today, and especially want to thank all 4 presenters. This was, an excellent webinar, and there's obviously a lot of discussion that can follow up. So we will archive today's presentation at arcus.org, SIPN's meetings and webinars, and encourage you all to follow up with questions to the individual presenters. Next slide, please. And as I said at the beginning, we would really welcome feedback for today's webinar. Please use the link that is in the chat and here online at SurveyMonkey, and we'll leave this link up for a few minutes after the close. With that, I just want to again thank everyone today. It's a lot of good discussion. I think there'll be a lot of good discussion online afterwards. And again, thank you to Hajo Eichen, Joe Little, Zeke Baker, and Marta Tirado, and Tamuyan Mong for organizing this webinar. This will close the webinar presentation, but we will leave the chat window open a little bit and encourage people to ask questions. I will work to connect people's questions with the presenters. Thank you.
Yeah. And thank you, Betsy, and the Arcus team. It's run so smoothly. Thank you.
Thank you.